Okay, here's a quick overview of lesson 6.1. Anytime you have a statement with a key word in it, your reason for that, if you have to justify it for whatever reason, or if you're writing a 2-column proof, your reason is always definition of, and then whatever that keyword is. Okay, for instance, number 4 on the lesson practice on page 65 says, angle 2 is supplementary to angle CBE. So your key word in that statement is supplementary. So your reason, or what justifies that statement, is definition of supplementary. The other thing that you see in this section is segment addition postulate. You also have angle addition postulate, same thing, but with angles. Okay, for segment addition, it's just 2 pieces of a segment that add up to get that whole distance. Okay, so if I'm looking at this problem, I have AB, okay, and I have BC. Okay, so you could say like this is 2 and this is 5. If I wanted to know the distance of the whole thing, I would just add 2 and 5. Well, it's the same thing here. The only difference is you're naming the segments instead of putting the numbers for the segments. So AB plus BC equals AC. That's the whole thing. Okay, and you see that on number 6 of the 6.1 lesson practice. Okay, that's segment addition postulate. It's talking about CB plus BF equals CF. Okay, that's the one that I went over here. It's talking about bisect, the key word. So your reason for that one is definition of bisect, okay? Or sometimes you'll see it say definition of angle bisector, since it's talking about bisecting an angle, but either way is fine. Okay, number 7, key word. So definition of right angle, or this sign means perpendicular, okay? Even though it's not a word that's written out, that's what that means. You would read this, line HD is perpendicular to line CF. So I could also say definition of perpendicular for this one. Okay, for number 8, it says if the measure of angle 3 equals the measure of angle 6. So I'm starting with this equation. Then the measure of angle 3 plus the measure of angle 2 equals the measure of angle 6 plus the measure of angle 2. Okay, you still have the measure of angle 3 and you still have the measure of angle 6. The only thing that's different from this equation to this one is that you have 2 on both sides now. Okay, the measure of angle 2. Well, how did they get that? They added, okay, there's a plus sign there. They added the measure of angle 2 to both sides of this equation. Okay, and you can't combine those. They're not like terms or anything. So it shows you that they added the measure of angle 2 to both sides. Okay, now if we look at section 6.2, the only one that I required y'all to do was number 4. So we're just going to fill out this proof. Okay. The very first reason, every single time, no matter what kind of proof it is, the very first reason is given. You have to start with what you're given. You can't start anywhere else but with what they give you. Okay. So that reason is given. Okay, like I just talked about, if your statement has a key word, okay, like our given does, bisects, the next reason is definition of whatever that key word is. So definition of bisect. Okay, and you can check that too. It says ray BE bisects angle DBC. Well, if that's in the middle, it's cutting it in half, bisecting it, then yeah, angle 2 and angle 3 would have to be congruent, because that's what bisect means. So definition of bisect. The next thing is I need to fill out this statement. Okay, this says definition of congruent angles. Okay, well, what is the definition of congruent? The definition of congruent is equal, or having the same measure. So if I'm using the definition of congruent, this says angle 2 is congruent to angle 3, then my statement must be that they are equal. And this is where you use the M, okay, because now I'm talking about the measure. So the measure of angle 2, so M angle 2 equals, instead of a congruent sign, equals M angle 3. Okay, now here's where we have a different kind of thing going on. The next statement says angle 1 is complementary to angle 2. Okay, sometimes you're given two different statements. So if this is after given, okay, the reason for that statement is given. Okay, so you can have given in two different places. Sometimes we had it for the first reason. Okay, always, that's never going to change. And sometimes you'll have it later on too. Then we're going to follow that same kind of pattern. This was given and it has a key word in it. So my next reason is the definition of that key word. So this would be definition of complementary. Okay, complementary with my key word. So this is definition of complementary. The only thing you need to do here is fill out the 90. Okay, complementary means two angles that add up to 90 degrees. Also, this should have an M here. It's not written. It was a typo. Okay, now I need to figure out how they got from statement 5 to statement 6. Okay, well, the only difference is here's a 2, here's a 3. Okay, so you still have measure of angle 1, you still have 90. The only thing is they replaced the 2 with a 3. Okay, what property allows you to replace something that is equal? Because remember in statement 3, we said those were equal. Okay, substitution allows us to do that. If I have two things that are equal, I can substitute or replace those values. So the reason for number 6 is substitution. Okay, and then the very last statement is easy to fill out. It's always what you had to prove. Once you prove that, that's it. That was the whole point in writing the 2-column proof. So the last statement is whatever comes after proof. So angle 1 is complementary to angle 3 is what you write right here.